Alright, so in this video we're going to explore different types of chemical reactions. And you're going to be able to identify a reaction as a combination, decomposition, single replacement, double replacement, or combustion reaction. So chemical reactions can be classified as combination reactions, decomposition reactions, single replacement reactions, double replacement reactions, or combustion reactions. When you have a combination reaction, two or more elements form one product. So simple compounds will combine to form one product. So you'll have an A and a B, or possibly a C. So you have two or more reactants. They are going to combine to yield one single product. So you can see examples of combination reactions listed. Alright, so this is just schematically showing you a combination reaction for the formation of magnesium oxide. We have magnesium metal plus oxygen, and they will combine to form magnesium oxide. In a decomposition reaction, one substance splits into two or more simpler substances. So you have a single reactant that will split into smaller parts. So you can see here, on the left, we have mercury oxide being split to mercury and oxygen. In the next reaction, we have potassium chlorate, and it will decompose into potassium chloride and oxygen. So again, schematically, what happens in a decomposition reaction, you have mercury oxide, you add some heat, and it's going to decompose into mercury liquid and oxygen gas. In a single replacement reaction, one element takes the place of a different element in another reacting compound. So here we have zinc solid and HCl. So what you can see is that it is a single replacement. The zinc replaces the hydrogen, forming zinc chloride and hydrogen gas. In the second reaction, you have iron and copper sulfate. The iron replaces the copper and forms iron sulfate and solid copper. So here schematically showing you what happens in this zinc chloride reaction. You have zinc metal that you put into a solution of HCl or hydrochloric acid. The zinc metal will form a zinc ion, a zinc 2+ ion, and hydrogen gas will form. In a double replacement reaction, the positive ions in the reactant compounds switch places. So you can see here we have two ionic compounds. We have silver nitrate and sodium chloride. In this double replacement reaction, the positive ions will switch places to form silver chloride, which is now a solid, and sodium nitrate, which remains aqueous. In the second reaction, we have zinc sulfide and hydrochloric acid. The zinc will swap with the hydrogen, and you see that you form zinc chloride and dihydrogen sulfide gas. So here we can see this double replacement reaction of barium sulfate. We start with sodium sulfate and barium chloride. When they are mixed together, we form barium sulfate, which can be observed as this white precipitate, and sodium chloride. In a combustion reaction, a carbon-containing compound burns in the presence of oxygen gas to form carbon dioxide and water. In a combustion reaction, energy is released as a product in the form of heat. So all combustion reactions will take this form where you have oxygen gas as a reactant with a carbon-containing compound, and the products are carbon dioxide, water, and energy. Combustion reactions are a source of heat. So when you have a propane heater or a fireplace or a wood stove, you need to make sure you have adequate ventilation. When the oxygen supply is limited, incomplete combustion occurs. And when you have incomplete combustion and you do not form carbon dioxide, you can form a product known as carbon monoxide. Carbon monoxide is toxic. When we learn about hemoglobin in our biochemistry chapters, we're going to see that carbon monoxide can displace oxygen from hemoglobin as it's carrying oxygen to our tissue. Depicted here, you can see the incomplete combustion of methane where you form carbon monoxide instead of carbon dioxide. So again, this is what I just said before. Carbon monoxide is a toxic gas. It is colorless and odorless. It attaches to hemoglobin and it will reduce the amount of oxygen that can reach our tissue and our cells. It causes a person to experience a reduction in exercise capability, visual perception, and manual dexterity. Hemoglobin is a carrier protein. It is found in the blood and it transports oxygen to the cells from the lungs. So just a 10% replacement of carbon monoxide for oxygen, a person may experience shortness of breath and a mild headache. 30% will increase the severity of your symptoms. And finally, 50% can cause a person to become unconscious and die if they are not treated with oxygen immediately. So in table 7.4, we have a summary of the different reaction types. We have combination, where you have simple reactants forming one product. Decomposition, where you have a reactant forming simple products. In single replacement, you have one element or atom displacing another from a compound. In double replacement, that is where the positive ions are switched. And finally, in a combustion reaction, you have a hydrocarbon, so something that contains carbon and hydrogen, and you have oxygen gas as a reactant, and your products will be carbon dioxide, water, and heat. Balancing combustion reactions can be a little tricky, and I'll go through it with you during the last learning check. So first we need to identify each reaction as combination, decomposition, combustion, single replacement, or double replacement. Pause your video and do so. Okay, so A we should see as single replacement. For B, we see that we have double replacement because the sodiums and the silvers swap. For C, we are going to have another single replacement where carbon is swapped for the iron. And then finally, the last reaction is a combustion reaction. So you can see A is single replacement, B is double replacement. There's obviously a discrepancy here because this was not the equation given. Had that been the equation given, that is a combination, but the one that's written previously is a single replacement. And then finally, our combustion reaction. All right, so here we have another learning check. So pause your video and identify the types of reactions we have present. The first reaction is a combination where you have simple reactants forming one product. The second, B, is going to be a single replacement where the silver replaces the hydrogen. C is a combustion reaction. D is a double replacement reaction. And E is a decomposition reaction. Before I just advance the slide to show you the answers, what I would like to do is I'd like to look at problem C and go through how to balance a combustion reaction. So I'm going to write the unbalanced equation where we have C2H6, which is a gas, plus oxygen, which is a gas, giving carbon dioxide, which is a gas, and water. Now the heat is not written down, but that's okay. Okay, so I said to you, when you have these types of reactions, balance the other atoms first. So you can see on the right side we have 2 carbons, so we need to put a 2 in front of that carbon dioxide. Now, let's try and balance the hydrogens. So you have 6 hydrogens on the left. So let's put a 3 in front of water. Now let's try and balance our oxygens. On the left side of the equation, you have 2 oxygens. On the right side of the equation, we have 4 oxygens plus 3 oxygens for a total of 7 oxygens. So in order to balance those oxygens, I'm going to put a fraction in front of the oxygen. I'm going to say we have 7 halves. Then what we're going to do is we are going to multiply the whole equation by 2. And when we do this, we can get rid of that fraction. So that we'll see that we have 2 times C2H6 plus 7 oxygens. Let me just put my states of matter in. That will give us 4 carbon dioxides plus 6 waters. So let's just see if we're balanced now. So we have 4 carbons and 12 hydrogens and 14 oxygens on the reactant side. And then we have 4 carbons, let's see, we have 8 oxygens plus 6 oxygens for a total of 14 oxygens. And then we have 12 hydrogens. Okay. So by using this fraction, right, so you're going to use some type of improper fraction of 1/2, and then you multiply the whole thing by 2 to balance the equation. So start with the carbons, then move on to the hydrogens, and last do the oxygens, and multiply everything by 2 to balance a combustion reaction. So here are your answers for A, B, and C. And then finally D and E. Right, so you should be able to identify the different types of reactions when presented with a chemical equation.